In this video, we're going to look at solving trig equations and trig equations in a specific form that we call linear form. So when I use the language of trigonometric equations, these are equations where we're going to have trigonometric functions, clearly, and constants only. So we're not going to combine trigonometric functions and polynomials. So something like sine x plus x, right? We're not going to see that sort of thing. Okay, and so some of these, like this first one, sine of x is equal to 1/2, we might already have a pretty good idea of how to solve it. We could say, well, we learned maybe in our previous education that if we want to isolate x, right, we need to get rid of sine. So then if we take sine of x, and I'm just going to rewrite this quickly in a specific way. I'm going to do 1/2 over there. Right, to get rid of sine, it is a function, so I can't just arbitrarily divide by it, but I could apply the inverse function to it to get rid of it. But what I do to one side, I have to do to the other side to maintain equality. So, okay, this is fine. And then the sine x's would reduce, and I'd be left with x is equal to sine inverse 1/2. And then we all, of course, reach for our calculators and we want to put this in. And if we do this, we get pi over 6. Okay, so yes, that is an answer. It is not the complete answer, though. Okay, remember that when we work with the inverse function, right, the inverse function here, that's restricted to a particular place within the unit circle. This is within the range of negative pi over 2 to positive pi over 2 inclusive. And so we are finding all the solutions in that interval, but right, we can have any angle. X here represents any angle. So we found one, there are infinitely many more. So how do we find all of those? And that's where you can see on the bottom of my screen, we have the unit circle back up in front of us. So, so yes, we certainly see that at 30 degrees, pi over 6, on the unit circle, sine, which is the y value, is 1/2. But I need to find all angles such that sine of x is equal to 1/2, or the y value is 1/2. Well, we certainly found one, and if I look around the unit circle at the y values, is there another place where sine of x is equal to 1/2, where the y value is 1/2? Yes, and that occurs at 150 degrees, or 5 pi over 6. So how do I get it? How do I get it from the algebra? And the answer is that it actually is a little bit more complicated than we maybe want to get into this video. You have to look at reference angles and then translate the reference angles, so you can do it. I just prefer to say, okay, once we get the trigonometric function isolated, let's go and look at the unit circle. Okay, so if we were to solve this completely, okay, I'll just kind of outline the actual solution. Okay, what I would say is that sine of x is equal to 1/2, and then what I would say is that in this case, x is equal to pi over 6, which is 30 degrees, and then remember, I have to remember that sine is a periodic function, so it repeats its value every 2 pi, and then I'm going to just do k, and k is just indicating the number of times you go around the unit circle. And then I'm also going to say, or to capture the other solution, x is equal to 5 pi over 6 plus, and then adding the period on just to account for all other possible angles. And I'm going to say k is an integer. Okay, so this would be the complete solution. All right, so that is what we need to do effectively in these exercises. Now, not everything's going to be as straightforward as what I just did above. So the general process is that we want to isolate the trig function first, okay? And then you can apply the inverse trig function if you wish, but you only get one value. Okay, so then what I recommend is actually once it's isolated, go directly into step 2, which is looking at the unit circle. Okay, use the unit circle, find all the angles that make the statement true. Okay, and then lastly, once you do that from the unit circle, incorporate the period. Okay, so here we go. I'm going to do one, and then I'm going to have you pause the video and try one on your own. Okay. In working with trig functions, so the linear ones, you're going to see something like both of these examples. For those of you that this might be a little intimidating. Cosine, right? Cosine is just going to produce a number. So if it's easier for you to think of this as the equation like 8a plus 3 square root of 2 is equal to 2a, you sure can. But moral of the story is to solve this, we need to isolate the trig function. So we need to get all the trig functions to one side, or put differently, as with any equation, get all the things with x on one side to get all the non-x's on the other. Okay, so I'm going to subtract 2 cosine x from both sides. And I'm also going to move the square root of 3, or 3 square root of 2 over to the other side. So subtract 3 square root of 2, subtract 3 square root of 2. And so then I have, on the right side, I'll have negative 3 square root of 2. On the left-hand side, 8 cosines take away 2 cosines gives me 6 cosine of x. Okay, and I want the trig function isolated, so I need to get rid of its coefficient. Divide by 6. Cosine x is equal to negative square root of 2. Reducing those gives me over 2. Okay, and now this is where I have the trig function isolated. I need to go to my unit circle and say, okay, on my unit circle, what are the angles, right? I'm looking for the angles where the x value, cosine, is square root of 3 over, or sorry, square root of 2 over 2 negative. So let's go back up here. Where on my unit circle is my x value negative square root of 2 over 2? Looks like it's right here at 135, and again at 225. And now with these, I guess it doesn't say, okay, so it says in the interval of 0 to 2 pi. You could do it in degrees if you wanted to. I just have a habit of doing it in radians. If it doesn't say in your answer, you pick. So I'm going to say x here, the angle is, let's see, it was 135, so 3 pi over 4. And then I'm going to tack on the period, right? So it would repeat every time we go around the circle, plus 2 pi k, or x is equal to 5 pi over 4 plus 2 pi k. Now, what we actually found if we read the instructions carefully is, so we have to find all solutions in the interval 0 to 2 pi, so within just one normal unit circle. And then we have to find the solution set over all real numbers. So using this k representation, or n whatever, this is actually going to encompass all possible answers ever, okay? Because k, we just say k is an integer, and so I'm just going to, that's a shortcut way of saying k is an integer. So k is in, and then it's a kind of a double or bolded z for the integers. And then so for part A, we would just say the answers are 3 pi over 4 and 5 pi over 4. Okay. So there we go. So again, what I did is I isolated the trig function, move all the trig functions to one side, got it so that it's just cosine, and then I use my unit circle. Okay. So there's another one. I want you to pause the video and try it on your own, and then resume when you're ready to see the solution. And here's my answer. Okay, let me just kind of talk through a few things. So first thing, I think we maybe got to isolating tangent just fine. From there, what I did is I actually kind of went another step. So it was square root of 3 over 1, and I know that that doesn't appear on the unit circle naturally, so I just divided the numerator and denominator by 2 so that that was more easy to find on the unit circle. And I found 2 pi over 3 and 5 pi over 3. That's fine. And then remember to tack on the period of tangent, which is pi. And then k again is that allowing it to repeat any number of times we go around the unit circle. Well, in case any multiple of the period. Okay. Now, if you had listed both of those as your answer, it's not wrong. It's just a little redundant, because if you think about it, if you do 2 pi over 3 and then plus pi times 1, okay, which is just pi, right? This would give you 5 pi over 3, okay, which is actually this answer. So what I'm trying to say is that the solution of 5 pi over 3 plus pi k is included within the 2 pi over 3 plus pi k. So it is redundant, and you could just list the one. Okay, and then for part A, it would just be listing those two values that we found based on the unit circle. Okay, so here are some basic trig functions or trig equations that we can solve. Again, just isolating trig functions and then using the unit circle.